Okay, so let's take a look together at problem number 4 on your homework problems on course compass here. So in the problem, what we have is a function. We have a function predefined g. The function name is g, taking the input argument x. So we have g of x equals 7 times x minus 5. And so once again, you can see that I intentionally verbalize it out how the function works. So here what the function does is it takes whatever the input x is, it multiplies 7 to x and minus 5. And now the homework problem number 4 is asking us to evaluate or find the indicated function's values. So here in part A we are supposed to plug 0 into the function. So let me now go ahead and switch over to my screen mode, and then we're gonna look at those problems together. So here we go. The function that we have. Okay, so for the function that we have, g of x equals 7x minus 5. So in part A we were asked to find g of 0. So what happened here is that what I need to do, once again, I need to substitute 0 into the x, because in the original functions x is acting as my input indicator. So in the function's formula, it's indicating that for whatever the input x equals to, I need to multiply the input to 7 and minus 5. So what I need to do is 7 times 0, because I am, if you can see now, I replace my x by a 0, an actual 0. I multiply the 0, which is my x input, to 7, and then I'm minus 5. And so here you need to, if you're not comfortable with the order of operations, make sure you review on your skills in order of operations. But here 7 times 0 of course must be done first. And so we have 7 times 0 equals 0 and minus 5. And so the final answer here, 0 minus 5 equals negative 5. And that is how you evaluate the function g of x at x equals 0. So if you look over to part B and allow me to switch back to the screen, and here actually, so part B of the problem, still the same function. We are being asked to find g of minus 2. So g of minus 2, same function, 7 times x. For x can be whatever the input is, 7 times x minus 5. So g of negative 2 is telling me that I need to substitute negative 2 into my function's formula for x. So here I have 7 times negative 2, and what you can see that in the original, if you look at the original formula itself and compare to what I'm doing now, so it just everything remains the same except for the x. The x here is replaced by a negative 2, okay, and which means 7 times negative 2 and minus 5. And now once again, at this point here, you can actually evaluate further. So according to the order of operation, you can do 7 times negative 2, which gives me negative 14, and minus 5, that equals minus 19. And this is the answer to g of negative 2. And this is the answer that you can enter in course compass. And so notice the problem here is from my own account, so it might differ a little bit on your account, but you are going to have the similar problems. So now let's look over to part C of the same problem here. Okay, so now we are being asked to find g of 9 over 7. So now at this point we've had about two examples showing you how to plug in a value and evaluate in a function. So now what we have here is nothing. It's not really anything different. The only thing now we have is a fraction. We are substituting the value of x by a fraction. So if you're not comfortable with fraction, make sure you review the lessons or the video for how to operate around with fractions. But here what I have is, once again, my function g. When x generally is an input for any general input x, the function does 7 times x or multiply x minus 5. And so here I'm just substituting my x by a 9/7. So as the way how the function sets up, we have 7 times 9/7 and then minus 5. Okay, and so now what's so good about this is, and once again I strongly recommend that if you're not comfortable with working on fraction, make sure you review your skills here on fraction. But here you have a number 7 multiply with 9/7, so you can cancel the 7 away. The 7 you can cancel with the denominator 7 here, and that leaves me 9 minus 5, and so the answer here is 4. And so that's what you can enter in your course compass input box right there. And let's look over to part D. Okay, so now part D is slightly different. Now I had an example like this in class, so hopefully you still remember. But what we have is, instead of putting in some particular value, now we're trying to put in the whole point is the whole point I want to show you earlier is that, remember we had a function, and we put in like a cat or a dog in class into the function. The point is just whatever the function is, you can just simply plug in any input, and then depending on the function how it works, depending on the functions, we can just simply allow me to get back to my screen here. Okay, so now in part D, so what I was trying to say earlier is that so now if you look at g here, g is still the same function. As long as we're working with g, the same name, we're looking at the same function here. But now the x here, this time I am putting in for my functions a little bit strange input. But now still, whatever the input is, you're just gonna what the function does to this input. Now here the whole thing is my input, negative 9b. So what the function does to this input is it's gonna multiply the entire input, negative 9b, multiply that to 7 and minus 5. And so what we had was, so now according to this, now keep in mind b is just simply another variable, so you don't really know what to do with 9b unless you have a value for b. But here the only thing we can do now is 7 times negative 9b equals to negative 63b minus 5, and this is all we can actually do. We cannot evaluate any further due to the fact that the variable b does not have a value attached to it. Okay, and then if you look back to your course compass problem, part F of the problem here is asking me to evaluate the function g at the input argument b plus 8. And so once again, it's the exact same idea. You just simply bring or substitute the entire argument here, the entire input here, replace that for the x in your original function formula. And so now what I have here is my function tells me that I multiply my input by a 7, and now the input is replaced by b plus 8. Okay, and then I minus 5. And so what I have here is, at this point, this current expression right here is telling me that I have a 7 times b plus 8 minus 5. And so what you need to do is just simply apply a little distributive law, and you can have 7 times b plus 7 times 8, which gives me 56 minus 5. And now you can just simply combine like terms. 56 minus 5 equals 51. So you have 7b plus 51 into your. So now this one here is what's to be ready to put into your Course Compass input box. So now let's see if Course Compass really likes our answer here. Okay, so now if I switch back to Course Compass problem, and now let me maximize this problem here. So part A I found earlier. Now if you look back at the video, part A I found that the answer is -5, and now I am going, and make sure you type in your most simplified answer. And so here, check the answer, and yes, Course Compass did like that. So now Course Compass now is asking for part B, g of -2, and what I found here is a -19. So, and let's see, Course Compass does like that answer. Okay, and so now for part C, the answer is what I found according to our work together. We found 4 as the final answer for that. So let's see if Course Compass likes it, and yes, it does. Okay, and part D, the answer is -63b -5. Okay, and yes, Course Compass does like that. Okay, and then lastly, the very last one, the answer here, according to what we had, finally 7b plus 51. And that is how Course Compass likes it. And that's how we complete problem number 4 in section 2.1.